Hey guys, it's been a while. Been really cool to kind of read along and hear about your 2018 and what you're looking forward to in 2019. It's been really cool to see. I hope you guys had a great holiday season and an awesome New Year's Day a couple days ago. Hope you've enjoyed spending some good time with your family, and I'm sure we're going to have a chance to talk about some of that coming up in the coming days. What I really want to do right now is to talk to you guys a little bit about where we're headed as we move forward over the next couple of weeks. And that is for us to really begin talking about something called factoring. I'm going to write that out real quick. Factoring. And factoring is really going to serve, for our purposes, it's going to serve as undistributing. So you think about using the distributive property. Maybe we see something like, let's start a new page here. Let's wipe this page clean. When we think about maybe that's not good. We think maybe about A times B plus C. When we use the distributive property, we would distribute and multiply that A to B and C, and we'd end up getting, of course, AB plus AC. And that is, we're pretty familiar with that. That's the distributive property. And when we go from this monomial times a binomial, and we end up with this distributed product here, we call that distribution, but we also need to have a mechanism or a way of getting back to our original there. If we think about math, any operations we've learned about, whether it's addition or subtraction, multiplication, etc., they all have an inverse operation. So when I add 5 to a number, if I want to undo that, I simply subtract 5. Or if I multiply by 10 and I want to undo it, I can divide by 10. We have to have a way of also undoing the distributive property. And that's kind of what we're going to be learning about in this video, just kind of get our brains thinking a little bit about that process of undistributing or factoring. And then we'll end up really kind of getting into depth with that when we get back to class in a couple of days. So I'm going to do an example here, and we're going to factor by looking for a GCF, or greatest common factor. So I'm going to start with an example that looks like 5x plus 10y. And I'm going to ask us to think about what is the greatest thing that these two terms have in common. They don't have the same variable. They don't share an x or share a y. But if we look at the numbers here, if we look at these coefficients, one of them is a 5 and one of them is a 10. So if we think about what is the biggest number that can be divided into either of those numbers. And of course the answer to that is 5. 5 is the biggest number that will go in to both of those numbers. And so if I think about pulling a 5 out of each of those terms, if I think about dividing a 5 out of each of those terms, what would be left behind in this 5x? If we divided out that 5, all that would be left would be an x. And over in the 10y, if we divided out a 5, all that would be left would be 2y. And if we want to just quickly double check and make sure that we've done this correctly, we can always think about distributing here. If I distributed this 5 to the x, I would get 5x. And if I distributed 5 to 2y, I would get 10y. That means that this is the correctly factored version of that expression. Let's try another one here. We think about 4y plus 8my. So this one's just slightly different because in addition to kind of dealing with the 4 and the 8, we also see that they have a variable in common. They have something here in common. So let's start with the numbers again. Let's go back to the 4 and the 8. And what is the biggest number that the 4 and the 8 have in common? And the biggest number they have in common is 4. And we think a little bit about the variables here. This guy has a y, and this one has an m and a y. So another thing that they have in common, part of their greatest common factor, is a y. It's going to leave us with 4y. And when we pull that 4 and that y out, if we divide 4y by 4y, we're going to just be left with 1 holding the place right there. And if we divide that 8 by 4, we're going to be left with a 2. And we divide it by y, so we don't need any more y's, but we're still missing that m here. And when we think back about, or we think to distributive property here, and we try to distribute this back, are we going to get the original expression back? 4y times 1, well, that's going to be 4y. And 4y times 2m, well, that's going to be 8my. And so, in fact, we do get back the original expression. So what we're really kind of trying to do as we make our way through this topic, at least to start, is we're trying to find that greatest common factor. And when we find that greatest common factor, we're going to factor it out. So that means we're going to pull it out to the front here, because it's something that both of those terms have in common, and we're going to see what's left behind after we've pulled it away. One more example for us to try, and that is I want us to take a look at 10x squared plus 5x. So let's start with those coefficients again. We have the number 10 and we have the number 5. And what is the largest number that they both have in common? And that number is 5. And then we go to look at the variables. Well, an x squared is just an xx. And the 5x has an x. And so what do they have in common? What do they have in common? Well, they have one x in common. They both can afford to give up an x. They both can be divided by x. So 5x is going to become part of this greatest common factor. And now, let's see what isn't part of that greatest common factor. So 5 times what is going to give me this original 10? Well, it's going to be 5 times 2. And we're supposed to have an x and an x, but right now we only have one x. That must mean that there's another left here behind, another x there left behind. And then on the next term, 5x times what is going to give me 5x? Well, it's just going to be 1. We need to write that one because it's kind of holding the place there. If I just didn't write anything, we wouldn't be able to distribute and get back what we started with. So let's distribute and make sure that we still agree that we think this is the answer, but let's double check. Let's distribute. 5x times 2x is 10x squared. That looks good. And 5x times 1 is 5x. Cool. So I'm going to give you guys a couple of simple examples to take a look at. And as usual, I will explain them. But this will kind of be the last thing that we're looking at. So let's take a look real quick. Let's do 2 different examples here. This one's for you to try all by yourself. 4ab plus 6a squared. Find the GCF. Cool. Now that you had a chance to find the GCF, we should have figured out that the number that they can both be divided by is 2. And they can both afford to give up. This one has an A and a B, and this one has an A and an A. They both can afford to give up an A. So the greatest common factor is 2A. And now, go ahead and finish factoring this. What's going to be left behind when I pull the 2 and the A out? Cool. So we're going to need another 2 inside here because 2 times 2 is 4. And we're going to need a B in here because we need to have an A and a B if we were to redistribute. Plus, 2 times what is 6? Well, that's going to be 3. And A times what is A squared? And that's going to be another A. That's going to be our factored form. And if we went back and distributed, 2A times 2B would be 4AB. 2A times 3A is 6A squared. All right, last one. Let's do one last example here. In this last example, we're actually going to do a trinomial. We're going to factor a trinomial here. And we're going to look at 16A squared plus 12 A minus 14B. Okay, let's take a look. So for the GCF here, let's start with the numbers. We have 16 and 12 and 14. And really the only number that will go into all three of these is the number 2. So we're going to start with a 2. And when we start looking at letters, we've got two A's here. We've got an A over here, and we've got a B over here. What letter do they all have in common? Well, they don't have anything in common. So there's not going to be a variable that's part of our GCF here. We're simply going to factor out 2, and that's going to make what's left behind in the parentheses pretty easy. 2 times what is going to give me 16a squared? Well, that's just going to be 8a squared. And 2 times what will be 12a? Well, that's going to be 6a. And 2 times what is minus 14b? That's going to be minus 7b. And again, if we were to distribute that 2, we should get the original thing back. This will be our factored form. And that's it. That's going to be all that you really need to think about as we move into Monday. We're going to continue to talk about greatest common factor and factoring in general when we get to class on Monday. And I hope you guys enjoy what's left of your break, and I will see you all soon. Bye.